Section 2.4, Properties of Quadratic Functions, Part 4, Example 5. Determine the quadratic function whose graph is given. So now we're given the graph and we have to figure out what the quadratic function is. Well, let's look at what we do know from looking at the graph. Well, we know that its vertex is 3, -4. I also know, what else do we know? We know the axes of symmetry. We also know the x-intercepts. We know the y-intercepts. So we know quite a few things about this graph. Okay. I don't think we need to write more information. I think this is enough. So let's write the standard form of a quadratic function. So if you remember, it's a times x minus h quantity squared plus k. So I already know what the vertex is. I know my h and I know my k. So I'm going to go ahead and just plug those in. So I have f of x is equal, so f of x equals a times x minus 3 quantity squared minus 4. Okay, so that's my h and my k from the vertex. Now I have a problem here. I still don't know what a is. Well, that's okay because I have many points that I can look at my graph for. But I'm going to choose just one. All I need is one. So I'm going to take 1, 0. So that means, so if I use that point, I can plug in 1 for x and 0 for y. Now remember that f of x is the same thing as y. So I'm just going to plug in 0 for f of x and 1 for x. Okay, so as you can see, that's going to help me solve for a. So let's go ahead and add 4 to both sides. And I get 4 equals a 1 minus 3, that's -2 squared. And that gives me -2 squared is 4, so that gives me 4a. If I divide 4 by 4 on both sides, I get a equals 1. So because I was looking for my a and that was the only thing I'm missing, I can go ahead and plug the a back into this function over here. So I get f of x equals 1. I don't have to write 1 since 1 times x minus 3 quantity squared is just x minus 3 quantity squared minus 4. I mean, if you did write 1 there, it's not wrong, but we don't really need to write it. So I'm just going to leave it like that. And that's it. We're done finding the function of that quadratic graph. Moving on to maximums and minimums. Note that maximums and minimums always occur where? Where do they always occur? So if you said the vertex, then you are correct. So they always occur at the vertex. Now, if we look at our first parabola that I drew for you here, so I'm looking at this one here. Okay, so I just highlighted so you know where I'm looking. That vertex there, is that a max or is that a minimum? So if you said minimum, you are correct. Now let's look at the second parabola. So now I'm looking at this other one that I highlighted. That one is that vertex is a maximum. So let's go ahead and finish my little note over here. I put, therefore, if f of x equals ax squared plus bx plus c has a less than 0, and if case you're not following, this is where I'm reading. Therefore, if f of x equals ax squared plus bx plus c has a less than 0, then the function has a blank at the vertex. then, sorry, that should say then. I'm not sure why it got erased. Then the function has a blank at the vertex. What does it have? So if a is negative, the parabola opens downward, right? So the parabola opens downward. So I'm going to go back up here. This is a is less than 0. Therefore, we have a maximum at the vertex. But if a is greater than 0, so now let's look at the first parabola. This is where a is greater than 0. The parabola opens upward. The function has a blank. Okay, if you said minimum, you are correct at the vertex. Now determine without graphing whether the quadratic function has a minimum value or a maximum value, then find that value. So let's look at our function. The only thing we really need to look at is that leading coefficient, which is -2. Since it's negative, I know that my parabola will open downward since a is less than 0, okay? And our a in this case is -2. So I know I have a maximum value at the vertex, okay? And just right here, f of x has a maximum value at the vertex. So how do I find that maximum value? Well, all we have to do is find the vertex. And we're not going to complete the square. We're just going to use this formula. X equals negative b over 2a. That's the x value of my vertex. So we have a, in this case, is -2 and b is 8. So I'm just going to plug in 8 for b and -2 for a. Okay, and if we simplify that, we get -8 over -4, which is +2. But that's only the x value. I still need to find the y value. So we need y value of vertex. Okay, and then all we have to do is find f of 2 to find the y value. So we plug f of 2 and simplify that, you should have gotten 11. Okay. So I just need to write my final answer, which is f of x has a maximum at 211. And that's my final answer.